you, Victor Tenorio, you are a mining engineer from starting in Peru and then having a master from Alaska Fairbanks and a PhD from Arizona. So you have moved around in America a fair bit. The research focuses on decision support system and smart mining for optimizing productivity. And you are now a professor of practice at the University of Arizona, teaching mining, and in particular of interest now, of course, the introduction to the moon mining. But you're now going to talk about the conceptual layout of a supervisory system for moon mine production monitoring and data analysis. Please proceed.
Okay.
All right, we need you to turn on your camera.
Yeah. It says here that it's been stopped by the host.
Oh, no. All right. Let's try that.
There you go.
There we go.
Hello.
Must be an automated thing.
Thank you, Ben, and thank you, Nicholas, for the introduction. I'm very pleased and very excited to be in this conference, and hopefully things that I will present will ignite ideas for what we might require in terms of supervisory centers. Let me share my screen. I am here, and 1, 2, 3. There you go. Let me put this on presentation mode. Okay. Give me a sec. I think I made it. Oh.
Can you make that full screen?
Yes, I will. I will.
Okay.
1 sec, please. Something is not working here. Give me one. I was still loading the presentation. I'm working on the cloud.
Oh, there you go.
It's coming. It's coming. It's coming. Yeah, you see it first than me. It's part of the time dilation here. Okay. Well, thank you very much. I'm going to talk about basically control rooms, or what types of control rooms are we expecting to find on our journey to the moon. Most of them center on or focus on mine production, but in general, for all the entire logistics that represents settling on the moon or moving from the Earth to the moon gradually. Okay, so we'll start. This is a very short outline. I will be covering a little bit of the requirements of the things that are needed for supervising our operations on the moon. And I start with just the general layout of Artemis, and we know already where we are. And basically, we finished phase 1, and we are ready for starting deploying equipment that is going to work by themselves. Many of them will be landers or similar types of equipment that will be sending equipment that might be working autonomously in many cases. And finally, the third stage, everybody knows that it will be walking back on the moon. This is a view of the moon as we already know it quite well. We have Terra, the highlands, we have the mare, the seas, and the South Pole, our main target for icy regolith and other materials in the permanently shadowed regions, and the equatorial region that hasn't been mentioned too much, but actually, at least in this presentation, will have some instrumental role. Okay, some of the challenges that we will find on the moon, many of these things are already known by everybody, but I just wanted to present them again. Basically, the harsh conditions of the moon, the temperature, the gravity, the remoteness itself. And for this, I try to kind of resemble things that happen when we go to remote mines far away from our homes, and how we can deal with this in many ways. Micrometeorites, the work cycles. I mean, we know that the 14 days of light and 14 days of darkness are kind of unconventional for humans, so we have to learn to live with that. Exposure to radiation, zero atmosphere, and dust. And the main activities that we are going to deal. I started with mining as a mining engineer, but there will be many more. Habitat construction and getting power in the industrialization that we have been listening about, how to be self-sustaining and create our own material, spare parts or construction materials, how to deal with waste, and then well, landscaping, if in case we want to put back some of the nice scenarios that we have on the moon. Okay, I took this from the motto of this conference, but just to kind of give the context to what we are going to need. Basically, our needs are settling, and also being able to monitor the work that we're doing. And the long-term goals is basically learning to live on the moon, learning to work and be self-sustainable. Let me see if there is a question or so. Okay, no, not for me. Okay, this is a very known diagram of the Earth and the moon and the Lagrange points. From these, the most critical or the most important are perhaps L1, Lagrange 1, the cislunar orbit, and more than the others. So here's where I lay out where are we going to work more intensely. This is not this is just one of the layouts, but basically what we're going to do is here we are. We start with the Earth mission control. We'll need Earth mission control. And then we're planning having at L1 the gateway. And the gateway will be a space station, but at the same time will be, as we are going to see, the port of entry, and also the place where people get adapted to before landing on the moon, and many more. So it has to be a well-furnished space station with capabilities of docking, and also deploying landers with materials or equipment for the surface of the moon, and so on. Then comes the equatorial base, and this concept that's when I am using the concept of having a base that is the closest distance from the gateway for landing, and for perhaps for launching, and many more. And also will serve as a sort of auxiliary or backup system for the South Pole mine site. We're going to have facilities in the South Pole mine site, and we will be working there. Let me see if there's questions here. Could the presenter please remove the stripe? Oh, yeah. Sorry, thank you. I'm going to remove this stripe. I think I can hide floating meeting controls, I guess. Yes, thank you. Thank you very much. All right. So first thing, part of what we need. Yes, go ahead.
Oh, there it goes. The stripe disappeared. It was sitting in the middle of the screen, but it's disappeared.
Yeah.
Sorry for the interruption.
No. Great. Okay. Yeah, it was interrupting me too. Okay. So, well, we know that Starship, SpaceX Starship Lunar, and how we're going to use it. We have seen in previous presentations how this is going to be tilted and cut in two, and we have now two hangars. So what some of the sources of materials, this is the simplest way, is to use the spacecraft that is going to land on the moon and use it. But this is just for our needs. One of our destinations, perhaps one of the more attractive places to start, is the Shackleton crater, as big as 13 miles apparently, and 2.6 miles deep, and very close to the South Pole. Some of the works are not necessarily going into this crater, because we see it here without almost any shadows, but actually it's pitch black all the time. So this is a special rendering done with all the images that we have got. And one target would be working at the bottom of the crater. However, around the crater, in many of these areas, like for example, here and here, we have flatter areas in where we can start. There are small craters also, and there is apparently sufficient abundance of icy regolith to start working. So we need to monitor these things and watch them from different locations. This is more or less the nature of the icy regolith that we're going to find, most likely in the flat areas, but it may also repeat in the bottom of the craters. The more dusty part, 0%. The next part, the large scale ejecta and others, will have like 4% of water, and then apparently the next 2.5 meters or so will be 10% water, and the rock will be harder and harder as we go deeper. This is my concept of I would say, the computer-based technologies that we're going to need on the moon. Many of them are mentioned and commented in many presentations, but some of them are technologies that are already having a presence on the earthbound technologies, especially for mining, and many of them are the only difference between these and the ones that we have on the Earth is drones. Because we may not be able to fly drones, we have to use other types of equipment, perhaps rovers and other equipment that will replace or substitute the need of drones for scanning or for surveying and others. But the others, all of them, including digital twin, will require supervisory systems, as it's mentioned also as part of the components. Others are Internet of Things, the data mining itself, data science in general for doing the analytics, and more. We have robotics, big data, and more. AI, of course, and more. And also I include in virtual and augmented reality, very valuable tools for this purpose. Some of the activities that will be required on the moon at any stage, from the early stage of pioneering, will be one of them, the most practical, is teleoperation. So we need to teleoperate some of this equipment and be able to control it. We need to deal with the delay. The delay from the Earth to the moon is difficult to teleoperate in real time. But if we are in the gateway, perhaps it will be better. If we are in the equatorial, well, this is a backup system, but on the South Pole, we may have safe locations in where we can work and not be exposed to the radiation and be comfortable and operate the equipment. We're talking about scoop trams or front end loaders or shovels or rock breakers. Many of these will be used eventually on the moon. Other technologies that are also very appropriate for this is mine automation. This is we see autonomous drilling, and here there's many brands, but the Sandvik Automation has a suite of technologies that are used for teleoperation to work in deep mines or remote mines and so on. And autonomous vehicles, autonomous trucks in particular, is becoming more and more developed. These are high tonnage trucks. This huge truck that we see here is 200 tons. And a razor is an equipment that carries 90 kilos or so. So it will be the proportion is different, but at some point we might upscale our operations. Virtual reality and augmented reality are wonderful tools. We can work from anywhere and be anywhere inside any location, underground, surface, in a mechanical shop, or in an assembly line, or in a process plant of any type, and we can have capability of seeing everything. And this is the beginning of some of the immersive tools that we will require and will be part of our centralized supervisory systems. We can do this from the same center and be able to monitor several operations, several locations in where we're going to extract our minerals or our site. Okay, this is a sort of a next chapter in where these are the ways of do studies of the lunar base, basically kind of recognizing the type of equipment we are going to see on the moon. And we can see here living areas, stations, warehouses, landers, and more. So some of them are here. Some of them are also known from public domain, many of them. This is a habitat for the moon pioneers. And we can see how they are sort of could be inflatable or could be constructed in different ways, but covered by the regolith in a way that we're protected from radiation. And also we can see some auxiliary equipment here. This could be whatever, a rock breaker or any type of equipment that might help for this, perhaps digging or not this one, but others, dosing or something else. Other equipment, this is part of the Lunox project, but I think I saw it, I found it very interesting. These are the landers. The landers are coming down directly from the gateway. So this could be the landing zone for the gateway, perhaps on the equatorial side for a starter, or properly driven to the South Pole, going directly to the site. And we can have all these types of equipment, rovers or wheeled or thread-based equipment that are going to help us on the mining process. Many of these steps might be autonomous by themselves. So the lander lands by itself in a destination point. The lander deploys the equipment, and the rovers kind of walk out or roll out from the platforms and start going to where their destination is being designated. So even if they are autonomous, our centralized supervisory systems needs to see where they are going, or we can change instructions, or we can solve problems if they have a traffic jam or some other difficulty. The same with the lunar rovers, and how these are the pressurized lunar rovers. Most likely that we are going to have people occupying and driving these rovers. Same thing, and the same concept that it's evolving. Landers are having different shapes depending on the type of equipment that they have. And same with what is called airlock node support module. These are components that we have seen in the first illustration of the moon bases. They are easy to assemble. One connects to the other, and you can have here a room or habitat, or other types of vessels that may contain oxygen, hydrogen, helium-3, or whatever we collect from the moon. This is a Lunox lunar outpost, so it's kind of more assembled, and I understand that Lunox is here kind of to provide well, in this case, could be fuel for the rovers and other equipment that might require, or some other way of other uses. It could be a habitat by itself, and they are just simply docking and working inside or so. Another part of this concept, but in a different scale, is the habitats, and we can see the space station by itself. It could be assembled and repeated and covered. As we can see, they have some sort of coverage over the entire module. And we see habitat. We can sit there. Again, we can have our own control room there, supervisory, and looks like a treadmill or sorry, a spinner to do some exercise. Now this is a kind of a representation of a rover that might be used for collecting samples, and these could be geologists, just like Jack Schmidt or the future geologists or selenologists. That's a very nice word for collecting samples or finding more deposits for mineral or mining works. And our favorite, one of my favorite, the Toyota Lunar Cruiser this is a concept that looks like the other rovers, but I think is very cool for its purpose. Okay, a little bit about control rooms by itself. This is a funny photo because it's evidently this is perhaps a, I don't know, oil refinery or something like that. And but there's an astronaut, and it's part of a publicity video that I found it interesting or catchy for the purpose. This is my view of the map of the supervisory systems that we may require on the moon. And I put the 4 destinations: the Earth, the Gateway, Equatorial Base, and South Polar Base. For the Earth, we are kind of familiarized. All that we have used for the Apollo systems, for the shuttle, for the Apollo project, the shuttle, and of course the space station. All of them are known and kind of familiar. We're familiarized with them. And big scale, small scale, big screens, and consoles. All of them are basically for assuring that we are going to reach safely our destination from the Earth all the way to the moon, or at least to the Gateway, and from there going down. Then the Gateway itself, that as I mentioned, is just for observation and control. And my favorites, considering it as a port of entry, to the moon. And this makes sense, especially I had experience to work in mines very, very high in the Andes and remote places that were extremely high. And we need, if you're going to work 4,000 or near 5,000 meters, we need a camp base. And the camp base would be at 3,000 or so. So we get used to the thin air and the conditions. Same thing here. The Gateway would be a base camp for the people who is going to land on the moon. The equatorial base exists because it's directly linked or connected to the Gateway. Means that from the Gateway, we're going to just drop the landers, and also the landers could be unmanned or manned for bringing the people there. And then we have to find out a way to move or convey or commute from the equatorial base to the South Polar base. And that would be perhaps a monorail. I proposed a monorail some time ago, or a train, other means of transportation that might take us there, or a rocket perhaps to go to the South Pole. It's not close. Anyway, the important thing is that the equatorial base is by itself a sort of a camp base for the South Pole, but at the same time, it's a backup system. Anything that we have at the South Polar base, we can repeat it at the equatorial base. Anything that may not work from the South Polar base for whatever reason it is, could be reproduced or and backed up by the equatorial base. So this is more or less the idea. And also we can have here the launch pads for going back to the Earth, or for going to Mars. So if we are, the intention is to have fuel with helium-3 or with hydrogen for the rockets in the future, this would be an ideal place. Another thing that I like from the equatorial base is that it's highly illuminated. It's not the permanent shadow regions, and you see the Earth closer to you, and also many things could be managed in a logistics and in other things before going directly to the South Pole. And then the South Pole itself, and many of the functions are more intensive and more detailed, including the mining cycle, habitat as well. Industrialization could be also there near the sources of material that we're going to use. So still we have to debate, as it was mentioned, I think Ben mentioned that we may have bases or settlements everywhere in the moon, the mare, the highlands. So we may have closer places in where we can kind of decentralize the work, not just the equatorial base and the South Polar base, but other places in where we can live and produce things and contribute with the industrialization of the moon. So this is kind of the map for all these areas, and we might infer what type of infrastructure is required. In the case of South Polar base and equatorial base, we can link them through a network of CubeSats that could be orbiting the moon and give us what we require. But on the South Polar Base, because of the nature of the autonomous technologies, we may need to have aisles or clusters of wireless mesh networks that will work specifically for the control and the quality of communications with the autonomous equipment that we may have. These are some examples. This is the mission control of the International Space Station in Moscow. So we see that have huge screen here for, of course, for the Earth and the orbits and the trajectories, and other 3D renderings of the equipment, the space station itself, or the Soyuz, or whichever we have, and the status of how they are, and a lot of small consoles, a lot of people who is also observing individual parts, including human health and more. And a big marquee or sort of panel that we have at the top that we may have information that comes updated. So this is the nature of a ground control or earth control or mission control station. Of course, and the gateway is still kind of in our minds, and I've seen a few nice renderings of what would look like. At the beginning, may look like a space station, perhaps similar to the International Space Station, modular and so on. But also we may need landing pads, docking ports or so. So it may have different shapes. And I use some artistic rendering, perhaps of a rocket, but I'm trying to show in a panoramic view how will the centralized supervisory systems may look in the gateway, which still has a little bit of spacecraft and a little bit of customs center or so, or mission control by itself. So this is kind of the idea of what we might be seeing in the gateway in the cislunar orbit. The equatorial base is just still conceptual. I have a few ideas, and this could be one that may have perhaps a storage for the fuel we're producing if we are going to launch and land in this area. I see at the right, I see landers. And also I see a farm of, perhaps this is just very modest, but solar panels. If we're in the equator, we might enjoy the direct sunlight that we might be receiving half of the time. And this comes to the different types of solar panel solutions, and also the kilopower solutions for the night. But basically, it's trying to show a sort of infrastructure rendering of infrastructure for that purpose.
Victor,
Yes.
2 minutes.
Yeah,
minutes.
okay.
Do you want to have time for a question, or do you want to wrap up?
Let me wrap up. I guess that will be
Okay.
good. It's not too much that I need to show, but basically I want to finish on the analytics that equatorial base may have. So we may use it beyond other things to do the analytics. And I have orange examples of different types of scatter plots and clustering that could be AI based for the finding the icy regolith. An on-site supervisory mining post, and this is kind of the view of what we can see supervising all the work. And we can have screens that may show us many things. I'm showing here an example. We can do teleoperation, energy, machine health, terrain, and human health for sure, and our virtual and augmented reality. An example, Earth-based from ABB, an extended operating workplace. And finally, this is just to show you, we can have also tablets. And this is an example that I've been doing a menu for a portable solution. This is just imaginary for the moment, but no, I did it last year. I did it in Python. I presented at the SME, so it was interesting. And these are the equipment that we already have seen. So I think with this, I will be finishing. This is the control room that we have at the university, and some of the papers we have been presenting. And some conclusions are basically what we have seen there. Main thing, the safety of humans, and the other is manage complex tasks and use all the tools for maximizing production and improve communications and teleoperation and other things. Well, that's it for now. Yes.
That's just on time. Thank you.
Yes, very good.
Thanks, Victor. Very, very informative.
Yep.
Very good. Thank you so much.